So we're going to do vector triangles where the vectors aren't at 90 degrees. So we've looked at a couple of approaches to adding vectors. We've done adding them using scale diagrams, which works. We've done adding them using components. I prefer the component approach. And today we're going to look at adding vectors that make awkward triangles that don't involve 90 degrees. And so we need to use two laws. We need to use cosine law. So the cosine law, c squared equals a squared plus b squared. And just when you thought you were done, and you thought that's a Pythagorean theorem, well, no, it's not. You just have to adjust the Pythagorean theorem because it's not a 90-degree triangle by a little bit. So a squared plus b squared minus 2ab cosine c. Once we're done using that, we're going to be using the sine law to find an angle. We're going to use this side, this relationship to find one of the sides. Now the big trick is to know how to label your triangle. So lowercase letters represent side lengths, uppercase letters represent angles. So angle C is involved in that relationship. And so if I have my triangle set up like this, where I have two vectors with 72 degrees between them, I'm going to label this angle as C because I know I've got that angle. Okay, now opposite that side is this length C, which is the sum of these two vectors. It doesn't matter which one is labeled A or B because addition and multiplication can be done in any order. And so I'm going to say that this is side A, and I'm going to say that this is side B. And that makes this angle A, and that makes this angle B. All right. Now that I've done that, I have my two vectors, and I have an angle between them, which I've painstakingly figured out what it is. I'm just going to plug everything into that formula, all the numbers that I've got, as well as the variables that I don't have, and then I'm going to evaluate until I can't anymore. Okay, so c squared, which is what I'm trying to find out, is equal to a squared, in other words, 4.25 squared, plus b squared, in other words, 4.5 squared, minus 2 times 4.25 times 4.5 times the cosine of 72, and make sure your calculator is in degrees when you do this one. Okay, so there's my great big long expression. So I'm going to take my calculator and I'm going to calculate what c squared is. I'm going to add and multiply and do everything in the right order, and I'm going to get 26.5, and I'm just going to say units because that's going to be in whatever unit I get. I'm not done yet. I need to take the square root of both sides. So the square root of c squared is just c. Square root of 25.5 is 5.1. And sorry, this should be units. This should be units squared. Okay, so good. Now I know that c is 5.1 units. Now I have a side that's across from an angle, and I want to find the direction that this vector BA is going. So I need to find this angle. I have a side across from an angle, as I've said. I have another side that's across from this angle. I'm going to put them into the sine law over here. Okay, so sine C is sine of 72, and that's across from 5.1. And that's equal to sine B. And that is across from side B, which is 4.5. And you'll notice I don't have to care about this one. I just need one angle. Now it's just a matter of isolating this sine B expression. And so I'm going to do that by multiplying both of these by 4.5. Lots of room, both sides. So the sine of B is equal to 0.83. To find out what angle B is, I use the inverse sine. Oh, do I have a mistake here?
Yeah, that one's 25.5, and that one's 26.5.
Oh, okay. Apparently I made a mistake. There you go. Technical people have told me this is 26.5. Okay, sine B is 0.83 on your calculator. You might have to hit second, or you might have to hit inverse, and you'll see a little thing that looks like sine with an exponent -1. It really isn't an exponent -1. It means the inverse function. You put a ratio into that inverse function, and it will return an angle. And that angle in this case is going to be B. And if we do that, we get 57.1 degrees. And so this angle is 57.1. So this is usually pretty awkward. You can do this using the component approach. Sometimes it's difficult to find out what the angles are because you're always given north, a certain number of degrees east, and you'll have to translate your angles into these parts. But nonetheless, it's a fairly solid system that works on triangles that aren't 90-degree triangles, and that's what most vectors are. So there we go. We've used the cosine law and the sine law.